Hello everybody, so Antoine here, and in this video I'm going to be discussing the most popular one-handed last layer methods. I'm going to be dividing these methods into two groups, so A and B. Names aren't all that original, but it doesn't really matter at this point. So basically, the difference between A and B is that the A methods can solve every possible last layer case. On the other hand, the B methods, are more like last layer subsets and can only solve the last layer when the pieces are in a particular way. So the first A method is OLLCP. This one's very common and used by most people. There'll also be the a bit lesser known CPEOLL and 2GLL. And then finally, I'm going to be discussing OLLCP and EPLL. Now for the B methods, I'm going to be discussing four of these. So the first one is OLS and PLL. That isn't strictly a last layer method since it solves the last slot as well, but I'm going to include it anyways because it's close enough. The next one is the quite popular as well, COLL and EPLL. Then I'm going to be discussing the ZBLL and finally 2GLL. So I'm going to start off explaining and discussing the B methods because the B methods also apply in the A methods. So first off is OLS and PLL. OLS is very vague, but I'm going to be talking a bit more specifically about winter variation. Number of algs, well, as I said, OLS is very vague. There could be stuff like RLS, which is, I think, over 300 algs. It includes also CLS, ELS, stuff like that. But I'm going to be concentrating on winter variation in this case, which is 21 algs, 27, sorry. And then plus PLL, which is another 21. So basically what this method is you have a pair that's already made, and you have edges oriented. And basically you orient the corners as you insert the last slot. So it's, as I said, 27 algorithms, and then you're going to be left with PLL. So what I think about this method, method, is that a lot of algs are pretty good. Most of them are 2gen, like the one I showed you right now. Some aren't all that great, but that's pretty normal. Most methods have bad cases. Yeah, it's a pretty good method to learn. Only 27 algs for the winter variation part, and PLL you should already know. So it's not that much effort. Recognition it's not very difficult. It's just corners. Just kind of like 2-look OLL. Also, you probably already know PLL, as I said, so it's pretty easy switch. So I would quite recommend you learn this one. There aren't that many cons on this method, mostly good sides. So yeah, that's about it for the winter variation. Next up is COLL EPLL. So basically what this method is when you are at last layer and you already have edges oriented, what you do is you recognize the alg, obviously, and what it does is that it solves the corner OLL along with the corner permutation. So basically you solve 2-look OLL, and then you're left with the U-perm. In total, there are 46 algs for both COLL and EPLL combined. However, if you don't want to learn students like me, it's only about 26 algs for the COLL part, and then you'd be left with PLL, so basically OLLPLL. What I think about this method? Well, I find that it's kind of like 2-look ZBLL, which I'm going to be discussing next, because you have to recognize the corners, and then you do an alg, and then you just recognize edges. I might talk about it a bit later. But the algs, they're decent, I guess. A lot of them you already know because the 2-look OLL. Uh, yeah, some cases aren't good. Recognition is okay. It's exactly the same thing as CLL on 2x2. Personally, I would recommend you learn all of the algs, except perhaps the soons. You might learn the soons if you like. I personally don't know them. I know a lot of other people like Phil Yu that use COLL but don't use the soons. So yeah, I think it's quite fast for one-handed since the algs are a lot of 2gen, RU, L also, and F. And you're left with EPLL, which is extremely fast for one-handed, as it's all 2gen. So yeah, in conclusion, it's pretty good algs. I think you should learn it. There's not all that much, especially if you're not learning students or anti-students. Just 26 and PLL, you'd already know it, especially EPLL. So yeah, the next method, ZBLL, is basically when you have the edges already oriented, and when you have that, you do an algorithm and you solve the rest of the cube. So for example, that. ZBLL can be extremely useful as it's one look last layer when you have edges oriented. And edges oriented isn't that difficult to get, so you can easily do it intuitively in the last slot, or learn full ZBLS, which is algorithm for every last slot case, which orient the edges. However, there are not many people that know it. Only a couple have ever learned the whole thing. Why, you may ask? There is a total of 472 algs for this. So yeah, that's a lot. Most people, myself included, only learn the best cases, and so basically the ones with the best algs and the easiest to recognize, and go along with that. Yeah, as I said, there's a lot of algs. A lot of them aren't all that great either. Some cases are pretty terrible, but a lot of the algorithms are quite easy and will save you a lot of time. Next, 2GLL. This is basically a subset of ZBLL. So it's when you have the edges already oriented and the corners already permuted. The way you normally recognize it is, well, you can either look if the corner's in place, but most people, I think, myself included, recognize the COLL case, so the corner case, and if it's one of the specific ones where the corners are not permuted, then they know that they have a 2GLL case. So for example, this case, this COLL, I know, has the corners unpermuted. Oh, and basically you just recognize the rest of the pattern on the cube. 2GLL has a total of 84 algs, or 60 if, like in COLL, you don't learn the soons. The recognition can be quite difficult. So for certain cases, especially the cases with all the four corners unoriented, especially in this case, it can be quite difficult to recognize the exact case. So some can be very difficult to differentiate. However, it's not all that difficult once you get used to it. A lot of the algs are great, as I said, because they're all R and U, except some algs are quite terrible. This one is actually not bad, but it's just a particular example I'm thinking of. So for like this case, the alg is... Yeah, the algs aren't all that great, but it's not all that bad, especially that they're all RU, and it's not that many algs. It's a fair bit, but it's... Okay, no, it is a lot of algs. 84 or 60, as I said. Now we're done Group B. Now for the Group A, where so basically it can solve every case. So first of all is the standard OLLPL, which I'm sure you know already. So basically you take a last layer case, you do an alg which solves the OLL, and then you do an alg which permutes the pieces, like that. So there are a total of 78 algs in OLLPLL, 57 OLLs, and 21 PLLs. You probably know it already, as I said. The algs are actually quite good for OH, if you know the right ones, of course. For example, on my site, I have one-handed OLLs and one-handed PLLs where you can learn them. A lot of the algs are R and U, well, RUL at least, or F. But yeah, some are pretty bad, but it's a quite good set. There's not really any really bad cases. Next, for the CPEOLL 2GLL, this one is a lot lesser known than the other methods I talked about in this video. So basically what it is you start off any last layer position, and then what you do is you do an alg which solves the edge orientation and the corner permutation. So basically what you're left with is the 2GLL. Like, for example, in this case, it can be good in some cases, like in this case. So here you have a crappy OLL and you're going to get a diagonal. Instead, you can just do an easy OLL like this, and you're left with an easy 2GLL. Like that. So it can be great for some cases like this one, and improve a lot, but for some other cases, like for example, this OLL, this last layer case, you'd have to do something like that, and then you'd be left with some kind of a 2GLL, which I don't actually know, and it'd be pretty long. But instead, you can just go and do OLLPLL, and you have a good case. So, as I said, it can be great for some cases, but it can be terrible for others. This case was just an average CPEOLL case, but yeah, the actual CPEOLL cases, the Algs I mean, they're actually quite nice. You can find a list of the Algs on my one-handed site. Most of them are R, U, occasionally the F move or whatever, but they're quite nice. What I don't like about this method is the recognition. You have to recognize which corner goes where. I'm not used to that because I normally do color recognition method for corners, so it's harder for me to adapt like that. But I'm sure once you're used to recognizing corners like that, you can do it relatively fast. But after the CPEOLL recognition, there's also 2GLL recognition, which isn't always the best. One of the biggest advantages of this method, however, is the number of algs. The actual CPEOLL is just 15 algs, plus the 2GLL if you know it. So that's for the CPEOLL. I hope you understood. Don't hesitate at all to comment. If you have any questions, I'll make sure to answer them. Now for the final OLLCP EPLL. So basically what OLLCP means is OLL and corner permutation. So you take a last layer case, and then you recognize the corner permutation. So then you do an alg, which will solve all the OLL and solve the corners. So you'll be left with either a U-perm, an H-perm, or a Z-perm. This can be quite nice for one-handed when the edges aren't already oriented, because it'll leave you with EPLL. Although for the OLLCP algs, there's a total of 336 algs, which is a lot. That's why I wouldn't recommend you learn the whole thing. However, it can be quite handy in some cases. So like for the same OLL I just showed you, you can also do another OLLCP, which will avoid you the need for a diagonal swap PLL or whatever, and it'll give you a nice 2gen EPLL. Most of the algs, well, you can't really say the algs are good or bad. It really depends on the alg itself. Generally, they're a bit worse than the OLLs because it's pretty much just alternate OLL algs. However, it can be extremely useful in some cases where there's a fast alg which will avoid a diagonal corner swap and will give you a nice EPLL. So that's it for the actual description of the methods. Now I'm just going to give you a quick conclusion on what I do and what I would recommend that you learn. I already gave you a few recommendations when I described the method, but I'm going to give you a bit more concrete stuff and say exactly what I do. So now, what do I recommend? What do I use? I would say learn the best from all worlds. So go over the alg list, check out whichever the easiest ones, whatever, if it's the easiest to recognize, the shortest algs, the ones that look like They're the fastest to perform. Whatever, just go check out the alg lists and find the best ones, learn them. Now, if ever you want to know like what order should I learn them in or where should I learn them from, I would suggest you start by learning some of one-handed PLL or OLL, and then you can go off with learning COLL. You can learn the students if you like. You don't need to learn them. And then if you like, you can go and venture in some more advanced stuff. So like some 2GLL, CPEOLL, and then there's of course the some OLS. Now, where to learn them? There are many resources online. So I would recommend for a lot of OH stuff. I have a site. I'll put a link in the description. There I have the one-handed PLLs, OLLs I use. I have one-handed COLL, one-handed CPEOLL, one-handed 2GLL, full lists. For other stuff like OLS, OLLCP, ZBLL, there's other places like the Boca Polish Algorithm Database. There's also a speed solving wiki. I'll put links to all of those in the description. So I hope this video was helpful. Don't forget, if you ever have any comments or questions, don't hesitate to comment in the video. I'll answer as best as I can. So that's it for the video. I hope you understood, and I hope it was helpful. Till the next time.